All right, today we're going to continue for the practice questions for chapter 2. Okay. Hopefully we can finish that. We have around 6, 9, 13 questions to finish today. Also about the first homework, I see more than 20 of us has started and several of us already submitted the homework. So that's very, very good. Okay. So yeah, if you haven't done so, please start the homework. If you have questions, you can either email me, you can call me, or even text message me. Some of you did that. So any piece of communication is welcome. Questions for the homework. Okay. All right. So last time we stopped
Professor.
here.
Professor, something's still wrong with your audio.
All right, I cannot see what is wrong with my audio. The microphone seems okay. Maybe the internet. Okay.
I have some background noise or something.
Okay, can you hear me okay now?
So far, so good. It might be your microphone.
Okay, I will not touch it anymore. Okay, yeah, let me know if the audio is broken again. Skip blinking. How about now? Is it okay?
So far, so good.
Okay. All right. Sorry. So yeah, bear with me. Last time we stopped page 23, question number 10. Okay. So that is the last question for chapter 1. So today we do page 60, question number 2. It is about probability, permutation, combination, where to use which equation. Okay, so yeah, let's do this practice together. Question number 2 is about die. Okay, so a die has 6 faces. It has painted on 3 of its faces. Okay, so 3 special die. So number 1 on 3 faces. Number 2 painted on 2 of its faces. Okay, and number 3 painted on the remaining 1 face. Okay. Assume that each face is equally likely to come up. Find a sample space. So sample space is all the possible outcomes for a certain experiment. So because this die is a special die, we only has 1, 2, or 3 possible outcomes. Okay, so sample space in this case is 1, 2, and 3. Okay, remember sample space means the list of all the possible outcomes of a certain experiment. Okay, that's part A. Part B is asking for a P odd number. So P is for probability. So that's the probability of odd number. Okay. So odd number including, so that is including P1. The probability has 1 plus P3, right? So for P1, because out of the 6 faces of the die, 3 faces has number 1. So P1 here will be 3 over 6 total outcomes. So 3 faces over 6 total faces. Okay. So P3, the probability has a 3. So because 3 has only 1 on 1 face, so that is 1 over 6. Okay, so the probability we have odd number will be 2 over 3. over simplification. Okay. Let's continue. Is asking if a die were loaded so that the face with the 3 on it were twice as likely to come up as each of the other 5 faces. Okay, so the face with number 3 twice as likely to come up compared with other 5 faces. So will this change the sample space? Okay, so for sample space, it actually doesn't change. So we still has 1, 1, 1, 1, 2, and 3. All the possible outcomes still doesn't change. Okay, right? But the probability we have 3 will change. Okay, this is how D asked. D asking if the die were loaded so that the face with the 3 on it were twice as likely to come up as each of the other 5 faces, will this change the value of P odd number? Okay, so if that's the case, P odd number. Okay, hold on a second. Somebody want to join us? Okay, P odd number before likely outcomes. Oh, the sound is really bad. Oh, let me just double check the connection. How about the sound right now?
So far.
So far, okay. All right. Okay. Yeah, just let me know. Just let me know. I don't know what happened today. Still glitching out? Restart the Zoom meeting. If you still has the glitching sound, so then I will restart the meeting. So it's still glitching the sound. If not, I'm gonna restart the Zoom. Okay, right now it's fine. Okay, all right. So let's just continue. Sorry about that. Okay. Let's list the equally likely outcomes. Because 1, we have 3 faces as number 1. So we will list 3 ones here. And we also have 2, number 2. Okay, so we have 2 here. We only have 1 number 3. However, the question tells us as the other faces. Okay, so we just put 2, 3 here. Okay, so these are all equally likely outcomes. Totally was 7. Okay, because for number 3, it is twice as likely. And then P number, you just P we have 1 plus probability we have 3. So P. All right. Let me do this. Maybe this is my microphone. Let me disconnect my. I use the microphone of my computer. See if you can hear me. Let me see, microphone. Okay. All right, so I'm using my computer's own microphone. Can you hear me better?
Yes.
Yes.
Okay. All right, so sorry about that. I don't know why. I purchased this like $100. I thought it's help me. Okay. All right. Anyhow,
which problem are we going over right now? Is it two?
Still number 2, page 60, question number 2, part D. Part D.
Okay.
Okay. Part D. All right. Right here, the P odd number, pay attention here, it will become P1 plus P3. P1 will be 3 over 7 now. Okay, so we have 3, 1, but the total equally likely outcome will be 7 now. Okay, so that's 3 over 7. P3, it will be 2 over 7. So we have 2, 3 here because 3 is twice as likely, and total number is 7. Okay, so that is, will be 5 over 7. 5 over 7. Okay. Question about the first problem today. Why we use 7, 3 over 7? Why we not use 3 over 6? No? Okay, good. Then let's continue. Question number 4. Okay, question number 4 is about counting method. So outcome are the 27 different strings of 3 choosing from conforming, downgraded. Conforming is C, downgraded is D, and scrap is S. Okay, sorry, let's read the question all together. Sorry. Here, 3 times each day. All right, 3 times each day, quality engineer sample a component from a recently manufactured batch and tested. Each part is classified as conforming, okay, downgraded, unsuitable for the intended purpose but useful for another purpose, or scrap, which is not useful. Okay. My experiment consists of recording the categories of the 3 parts testing a particular day. Okay. So A lists the 27 outcomes in the sample space. Okay. So 3 chosen from the either conforming, C, downgraded, D, or scrap. Okay, so we can using counting method to do the 27 outcomes. Okay. So 3 parts. Let's see, the first part could be C, D, or S. Right? So for the second part, it could also be C, D, S. C, D, S. And third part is also for each of these 9 from the second step. That's 9 total, right? So we also have CDS, CDS, and so on. For the last one, we also have CDS. All right. So using the counting method, it will be first step, we have 3 choice. Second step, we also have 3. Third one, we also have 3. So 3 times 3 times 3, so equal to 27. Okay, so these are the possible outcomes. Okay, will be CCC, the first one, right? CCC or CCD or CCS. Okay, then the first one will CDC, CDD, CDS, and so on. So 27 of them. Okay. B, A, is the event that all the parts fall into the same category. So fall into the same category. So that's part B, this part A. So it will be, could be all the three parts is conforming, CCC, or DDD, or downgraded, or SSS, or scrapped. Okay, so that's number B. Part C, that B be the event that there's no one part, that's the one part in each category. Okay, and this all come in B. Still, there's no easier way to do that. You just look at all the 27 possible outcomes, make sure no one is repeat. Okay, for example, we could have CDS, okay, or CSD, DCS, okay, DSC, SCD, SDC, okay? So one part in each category, okay? So again, there's no easy way. You just count all the 27 and see which one satisfy the requirement. So we have 6, okay? 6 for B. Then part D. So C is the event that at least two parts are conforming. At least 2 parts are conforming. So it could be 2 conforming or 3 conforming. Okay. So let's just again do the counting. So at least 2 conforming, it could be CCD or CCS, okay, or CDC, CSC, DCC, SCC, and don't forget the last one, CCC. Okay, so at least 2 conforming. So if 3 conforming, still satisfy. Okay, so CCC. So how many we have? 1, 2, 3. So 7. 7. Right. Part E. All right. So here, just check our knowledge about what is union. Okay, A or B, or A and B. Okay, the half circle facing down is and. Okay, the intersection of these two. Half circle facing up is or. Okay, so either in A or B, or in both A and B. Okay, so look at E. E is asking A and C. Okay. A and C. So look at A here and look at C here. Okay. So A and C means the event occurs in both A and C. Then CCC here in both A and C. So CCC is one of them. How about DDD? DDD is in A but not in C. Okay, so DDD is not. How about SSS? So SSS is in A but not in C. So only one. So only CCC belong to A and C. Okay. So half circle facing down means and. Okay, occurs in both A and C. If you see the Venn diagram, the multiple circles, that is intersection between 2 circles of A and C. Okay. Then questions? F. Least outcome of A half circle facing up is or. A or B.
I'm sorry, say that again.
half circle facing up is OR.
Or, okay.
Or, okay? So occurs in, if you see the Venn diagram, two circles A and B, is anywhere inside these two circles, satisfy A or B. What is A and B? A and B is only the intersection here. So this is A and B. Okay? So this is A and B. And that is A or B. Okay? All this shaded area, that is A or B. Okay. So A or B contains outcome that are either in A or B or in both. Okay, so that is easy. We just put everything in A and in B in that samples in that space. Okay, but do not repeat. Do not repeat. Okay.
Is there a certain order that we should put these in, or does it really matter?
Order doesn't matter. Order doesn't matter. Okay, so everything in A or B or both. Okay, you just put it in here. Okay, because this is OR, it is AND. Okay. Any questions or comments?
Well, I was thinking that even though you said that order doesn't matter, it's almost better to put it in the order that it comes in, so you can kind of keep track of it, keep a better account.
Of course, yeah. As long as you don't miss, but yeah, if the order, order doesn't matter. As long as you put everything inside it, and do not repeat and do not miss anything. Okay. Yeah. G is asking, list the outcomes of this one. What is this? Okay. So what is CC here? So C, is called complement or not C. Okay. So basically CC means all the sample items not in C is CC. Okay. Or the opposite of C. Okay. All right. The question asking here is A and complement of C. Okay. So you do the counting. Two sample items satisfy. Okay. So this is A and complement of C. So from the Venn diagram, okay, if this circle is A, if that circle is C, okay, so that means A and not C will be this area. Okay, it is in A, but not in C, outside the circle of C. Okay. H, list outcome of AC and C. So AC means complement of A and C. Okay. That means this is A, this is C. Okay. So not in A, but in C here. So outside circle of A that is complement of A, and in C, it will be this shaded area. Okay. If you do the counting, it will be CCD, CCS, CDC, CSC, DCC, and SCC. Okay, so that is H. Then I is asking, are event A and C mutually exclusive? Okay, first of all, what is mutually exclusive? So two events, if they have nothing in common, then we call that mutually exclusive. For example, from the Venn diagram, they do not have any intersection. The two circles does not touch each other, then we call that mutually exclusive. Okay, we can check A and C, and we found out they have something in common, CCC. So A has CCC, C also has CCC. Okay, so then we cannot say they are mutually exclusive. So the answer is no, not mutually exclusive. Last part, J, are event B and C mutually exclusive? We just check the event in B and C, see if they have anything in common. Turned out they have nothing in common. So yes, B and C are mutually exclusive. Mutually exclusive. Okay, so this question review the concepts. First of all, the counting method, okay, all the sample space. Then what is AND, what is OR, and what is complement, okay, and what is mutually exclusive. Okay.
I'm sorry, could you explain problem I again?
Okay, I is asking when A or C, A and C are mutually exclusive. So A is here, C is here. You just check if they have anything in common. They have something in common, which is CCC.
I'm sorry, what was that? They have something in common. What was it again? They have
CCC here. CC. Okay.
Okay.
So CCC belong to both A and C.
So they're not mutually exclusive because they both have CCC in common.
Yes. If you draw the Venn diagram, this is circle A. This is circle, what is C? Okay. So here they have something in common, which is CCC. So CCC is belong to the intersection of A and C. Okay. So they are not mutually exclusive.
And B and C are mutually exclusive because they have nothing in common.
Correct.
Okay.
Okay. Any other questions? Okay. Yeah, let's go slow. You know, we don't need to rush. I think we are pretty much on schedule, even ahead of schedule. So that is question number 4. Okay. Next one, question number 10. Question number 10. Okay. The article high cumulative risk of lung cancer, deaths among smokers and non-smokers, okay, from certain journal papers, okay, state that the probability is 24% that a man who is a heavy smoker will contract lung cancer. Okay, true or false? Okay, this question is about check our understanding of the correlation between sample and the population. Okay. A, in a sample of 100 men who are heavy smoker, exactly 24 of them will contract lung cancer. Okay, the question tells us 24% a man who is heavy smoker will contract lung cancer. So this is the information about the whole population. Okay, if we take a sample of 100 men, then how many of them will contract lung cancer? Okay, we will be close to 24% or 24, okay, but may not be exactly the same. Okay, so the question is exactly 24 of them will contract lung cancer. It's not correct. Okay?
False.
False. Yeah. B, in a sample of 100 men who are heavy smoker, the number who will contract lung cancer is likely to be close to 24, but not exactly equal to 24. Okay, that's perfectly true. That's correct.
True.
Okay, true. C, as more and more heavy smoker men are sampled, the proportion who contract lung cancer will approach 0.24. Is this true?
True.
This is also true. Okay, so this is the definition of probability. So when you increase the sample size, approaching the size of the whole population, it will closer to that 24%, which is the probability for the whole population. Okay. Question number 10. 14. Okay. So question number 14, 600 paving stone were examined for cracks. Okay. So 15 were found to be cracked. Okay. And the same 600 stone are then examined for discoloration, and 27 of them found to be discolored. A total of 562 stones were neither cracked nor discolored. Okay. And then one of the 600 stones is selected at random. Okay. So the best way to resolve this kind of problem is you draw a Venn diagram. Okay. Okay. And based on the information from the questions.
I'm sorry. Professor, what kind of problem is this again? Is this a sample problem?
What do you mean sample problem?
No, if for number 10, you told us that there was a sample and population type of problem.
Yeah, that's the concept.
What kind of problem?
Oh.
Okay.
Okay. Yeah. For this question, you just, check us about understanding of intersection, for example, or complement. Okay. So the question tells us this information. Okay. Let's see if the circle, we define one circle is C. C is for cracked. Okay. And another, correct. The other one is discolored. We call that D. Okay, let's put two circles, C and D there. Okay. So 50 of them are cracked. So that circle is 15. The total is 600. So the full sample space is 600. 27 discolored. Okay. So for the circle of D is 27. Right. Also, what other information? Totally 562 are neither cracked or nor discolored. So where it is 562 belong to the Venn diagram?
In the middle where they intersect.
No, the question tells us 562 are neither cracked nor discolored. So that 562 should be anywhere outside the circle of C and D. Neither nor, okay? So
Oh.
C and D. Okay. And we also know the total is 600. So 600 minus 562, we have 38. Okay. So that 38 will be the total number of samples in C and D or both. Okay. All right. First of all, A. But the property that is cracked, discolored, or both. Okay. Because we have 562, neither cracked nor discolored. Okay. So 600 minus 562 is 38. So these 38 stones were cracked, discolored, or both. Okay. So anywhere within these two circles, C and D. The question is asking for the probability. Okay. So that will be 38 over the total sample space. Okay. So question about this part. Okay. The question is continue, part B. So B is asking the probability that is both cracked and discolored. So P, C is for cracked, and discolored. So P, C, and D. Again, this is and. Okay.
I'm sorry, Professor, for number A, should we leave it like that or should we give a decimal approximation?
Yeah, you can give a decimal of approximation. Yeah, sure. In the exam, yeah. But in a paper-based exam, if you just list it, that's okay. But I think the computer, just give the decimal. Okay, give the number. Okay, so we want to find P, C, and D. Okay, and the question tells us PC. Okay, PC. So we have 15 of them, correct? Okay, so PC is 15 over 600. $15,600. Okay. And PD is 27. Okay, 27 over 600. Okay. The question also tells us, from the part A, we know the probability of C half circle facing up. This is R. C or D
is 38 over 600. All right. So we want to know PC and D. So that is equal to PC plus PD minus PC and D. PC and D. Okay. Sorry, it's not equal to. So this part, PC plus PD minus PC and D is equal to PC or D. Okay, so that's one of the equation we learned in chapter 2. Okay. The physical meaning of that, if we, again, we use the Venn diagram. Okay, so PC or D, this is all the areas within the circle of C and D. Okay, here. So that is equal to PC, the circle of C, plus PD, the circle of D. Okay, so PC plus PD, you realize we add the intersection of C and D twice. Okay, we add this part twice, so we need to minus that part. Okay, so from the Venn diagram, we can better understand why this equation holds true. Okay, or you can just remember that equation. So plug in the number. PC 0.025 is here, and PD is 0.045. Okay, the only unknown will be PC and D. So turned out it will equal to 0.0067. Okay. Questions on part B?
I'm a little confused here.
Yeah. If you understand what is OR, okay, so the PC or D is just anywhere within this circle of C and D. Okay, any points within C and D. Okay, so that is equal to PC plus PD minus PC and D. So this equation, we discussed in chapter 2. Okay, and
so if I'm not mistaken, if I understand this correctly, the solution for B is the same solution as A? Is the same solution? 38 over 600?
No. We want to find out what is PC and D, right? And this part is here. We want to find out PC and D. We plug in this equation. And within that equation, right now, we figure out all the remaining part, PC, PD, and PC or D. Right? We plug in the known number, and then the only unknown will be PC and D. So the answer is this.
Okay, I'm just trying to follow your
Okay.
So it's PC plus PD minus
PC and D.
Minus PC and D.
Yes.
Equals PC or D.
Yes. You should remember this equation. This is very important. Tell us the correlation between and or and individual probability. Okay, and you can focus on a Venn diagram to help you understand why this equation holds true. Okay. So you think about PC, the circle of C right here, plus PD, the circle of D here, all right? And PC plus PD, you added the intersection twice, did you? That's why you need to minus the intersection.
Okay.
Okay. Okay. Part C. Part C, find a property that is correct but not discolored. Okay. Not discolored. So the question is asking PC correct but not discolored. Okay, so that is PC and complement of discolor, not D. Okay, so that part is, again, go back to the Venn diagram. So where it belongs to, okay. So PC, so this is circle of C, but not D. Okay, outside circle D, but within circle C is here. Here. So from the previous part, we found out PC and D is equal to 0.0067, okay? And if that number times 600, that will be equal to 4, okay? So that tells us the intersection between C and D, we have 4 items here, okay? Then we can easily figure out all the remaining questions. For example, the circle of D is 27. 27 of them discolored, okay? And then 4 of them is both correct and discolored. Then in this area, okay, is 23, sorry, because 27 minus 4 is 23. Okay, and the circle of C is 15, right? And intersection of C and D is 4. So this area, which is question part C asked, will be 15 minus 4, which is 11. And this is 4 here. Okay, so the question is asking PC and not D is here, this area. So that is equal to 11 over 600. Okay. Questions? Okay.
This problem was similar to the other one. It's slightly different, but you could set it up where it's PC minus P, C, and D?
I didn't follow your question.
So you wrote that first equation, right? P, C, and is that the complement of D?
You mean here?
That little C right next to the D?
Yeah, it's complement.
That means complement, right?
Yeah, right now you should, it's complement.
So you could rewrite that equation PC minus P times C and D.
Yeah, yeah.
Right?
Yeah.
And then because we know what PC is from the previous question,
yeah,
and we know what P times C and D is from the previous question.
There's definitely more than one way to resolve the question. Okay.
Yeah.
Yeah. Okay. Okay, so that's question number 14. Question number 16 is easier. It's here. Okay. Question number 16. A system contains two components, A and B. Okay. All right, so this is pretty much the same concept we checked before. So A and B. The system will function as long as either A or B functions. Okay. The probability of A functions is 0.95. Probability B function is 0.9. Okay. Probability both function is 0.88. Okay. What are probability the system functions? Okay. The question asking tells us system functions as long as either A or B functions. So that will be PA or B after the coefficient up. Okay. So that is equal to PA plus PB minus PA and B. Okay. Okay. Again, this is A, this is B. Okay. So PA or B will be anywhere within that two circles. That will be PA is here, okay, plus PB is here. And we notice that the intersection of A and B is added twice. So we need to minus the intersection PA and B. So minus that part will be PA or B. Okay. So PA is 95%. PB is 90. PA and B is 88%. So 0.97. Right. Again, this question review the equation, which is similar to this, exactly the same. Okay. Question number 18 now. Looking at here. So human blood may contains either or both of two antigens, A and B. So blood that contains only the A antigens is called type A. Contain only the B antigen is called type B. And contain both antigens is called type AB. Okay, so we know, yeah, this is blood type. Blood that contains neither antigens is called type O. Okay, let's draw diagram. Okay. Yeah, certain blood bank, 35% of blood donor has type A blood. Okay. So let's say this is high sample space. The total is 100. Okay. And let's circle A, circle B. Okay. And 35 is type A blood. Okay. However, 35 is not the whole circle of A because the intersection between A and B, they have a name. This is AB. Okay, it's called AB. Okay, so 35 is just here. Okay, then 10% have type B. So B is here, 10%. Okay, and 5% have type AB. So here is 5. Okay. Then the outside will be type O. Okay. So anything outside AB will be type O. So we can easily figure out how many in O. Okay. So 100 times 35 times 10, minus 10 minus 5. Okay. So that is equal to 40. That's 50. Okay. 50 is type O. Hey, what is probably that random choosing blood donor is type O? Okay. So PO is 1 minus P not O, okay, or complement of O. Okay. So that would be 1 minus PA plus PB plus PAB. Okay, PAB. Okay, and PA is 0.35, PB is 0.1, PAB is 0.05. Okay, so 0.5. So this question, a little bit difference is do not confuse 35 as the whole circle of A, okay? Because the intersection between A and B, they have a special name they call the blood AB. So that's the a little bit the tricky part for this, okay?
I'm not understanding. So you put the probability of O. Is that what the PO stands for?
Yes. So the blood type O does not have A or B. Okay. So also,
that's why you used it. Okay, I was just trying to
yeah. You know, this is
understand
people's blood type, right? So yeah. So O means you don't have A antigen or B antigen. Okay. So anything outside these two circle of AB belong to O. Belong to O.
And okay, so this is still part A of the question that we're solving, right?
Yeah, this is part A.
Okay.
Part A. Okay. Part B. Okay, so a recipient with type A blood may safely receive blood from a donor whose blood does not contain the B antigen. What is the probability that a randomly chosen blood donor may donate to a recipient with type A blood? Okay, so as long as the donor does not have type B antigen, we'll be okay. Okay, so the question we are asking, the probability does not have B antigen. Okay, so that'd be 1 minus the probability has B antigen. Okay, so the property has B antigen will be two parts. One is it has type B blood. The other one is the type AB blood. Okay, and the type B blood will be 0.1. Okay, it's here 10, and type AB blood will be 0.05. Correct? Okay, so the answer will be 0.85. So outside the circle of B will be safe to donate blood to a recipient with type A antigen. Okay. Questions for this? Question number 18. Let me see if we have time to do next. Page 68. Sorry. 68. Question number 2. So let's do this question. So metallurgist is designing an experiment to determine the effect of flux, base metal, and energy input on the hardness of the weld. Okay, I don't think we have a class on welding. Okay, so basically when you do welding, the property of the weld is depending on many factors. And here it tells us determining based on the effect of the flux, the base metal, and also the energy. So 3 factors. Okay. So we want to study 4 different flux. Okay, question number 2. So flux, 4 type, base metal has 2 different, and 3 different amount of energy input. So energy input is 3 type. Okay, and if each one of the experiment involved a choice, 1 flux, 1 base metal, and 1 amount of energy, how many different runs are possible? Okay, so this is a simple counting method. You can think this experiment, which include 3 steps. 1, we choose the flux. Okay. So step 1, flux. Okay, and she has 4 different choices. The second, base metal. So 2. And third step, energy input. 3. Okay, so the 3 steps we times, so 4 times 2 times 3. So 24. Okay, 24 steps. Okay. Okay, so let's do the next question as our last question. Question number 6. Okay. So a college math department consisting of 10 faculty members must choose a department head assistant department head, and the faculty senate representative. How many ways can this be done? Okay, so we should think this experiment as, how many steps? Okay, so we have 10 people, and we should choose department head, okay, assistant department head, and senate representative. Okay, we use 10. Choose from these 10 faculties. So, which counting method we should use? We should use combination or permutation. Okay. Combination means when the order does not matter. Okay. When the order does matter, then we should use permutation. Okay. So in these questions, does the order matters? We know we should choose 3 from 10 total faculties. Should we use P310 or C310? Anybody want to have a guess? Should we use P or T, or permutation or combination?
Combination.
Combination. Why we should use combination, not permutation?
Because order doesn't matter.
The order does matter or not matter?
Oh, it does not matter.
Does not matter? Why the order does not matter? So if we see, we just choose 3 faculty from these 10 faculties, okay? And then that's it. If that's the case, we should use combination. So we choose 3 from the 10, then we done our job. No more works, no more steps. In our case, we choose 3. Then the next step, we're gonna assign department head from one of these 3 chosen, and then assistant department head, and then the remaining will be the senate representative. Okay. So in our case, the order does matter. Okay. There's several ways to resolve this problem. Okay. So first, let's see method number 1. We can simply, if you know this is permutation questions, then you should directly use P310. Okay, so P310 is right. That's 10 times 9 times 8. Okay, so that's method number 1. Okay, or you can think the other way in method number 2. Okay. In method number 2, you can think this experiment as 2 steps. The first step is we just pick 3 professors from the 10 total. Okay. First step is we choose 3. Okay. So how many different ways we can do? Choose 3 from the 10. C, right? C310. Because we just choose 3. We choose 3 professors from the 10 total. And let's say for the first step. So that should be C310. That's combination. And then we are not done yet. The second step, we should assign these 3 chosen professors to 3 different positions. Okay. The second step is assign 3 professors to 3 positions. Okay. How many different ways? So we have 3 people, 3 positions. So that's gonna be, we choose one for the first position, which is department head. So we have 3. Then we choose one from the remaining 2 for the assistant department head times 2. Then the remaining professor left will be Senate representative times 1. Okay, so there will be first step, say 3 times second step, which is 3 times 2 times 1. You get the same answer as this one. Okay. Okay. You also think the different way. You know, we method number 3. Okay. You can think this experiment as 3 steps. The first step is we choose one professor from the 10 professor and assign him or her to the department head position. Okay. So choose 1 from 10 for department head. How many ways? Okay, because we run out of time. Very easy, 10 ways, right? We have 10 professors, we choose one position, department head. So we have 10 ways to do that. The second step, we choose one professor from 9, okay? Because we pick one already, we have 9 professors remaining. For the second position, which is assistant department head, how many ways? 9.
8.
9. The second step is 9. We have 9 professors.
Okay.
So for the assistant department head, so we have 9 choices. And the third one, we choose one from the remaining 8 professors for Senate representative. Then we have 8. Okay? So 9 times 10 times 9 times 8. Okay? We got the same answer, 720 different choices. Okay, so you could think using either this one of these 3 methods, okay, depending on how you analyze this experiment, using either permutation or think about the steps, 1, 2, 3 steps, or think about 2 steps. One is combination, the other one is choose 3 for the remaining 3 positions. Okay, you will all get the same. Okay, so let's stop for today.